Good afternoon, and as usual, welcome to today's MANIAC talk. And we're also fortunate to have Professor Jagadish Shukla. So please, let's give him a warm welcome with a round of applause.
He really knows how to do it.
As is, of course, usual with these talks, we don't do a formal introduction, but I want to make a few remarks about Shukla. Now, as a boy, of course, we all know he was born in India, a small village called Balia district of India. Shukla walked bare feet all the way to school, and also while he was glazing cows. He learned Sanskrit and math under kerosene lamp. Some of you may not know what that means. I know about it. So kerosene lamp, if you're using it as a source of light, it's also producing gases, which also are not comfortable. So you can actually imagine somebody reading and there's this smoke coming from this kerosene lamp. So it's pretty interesting. Also, he used to use the bullock carts and elephants for transportation, and somehow ended up at MIT and also at Goddard. So what a journey, you know. Now his lecture today will include a personal retrospective of the origins of the idea of predictability, and of course I must say that some of that work has been recognized by the by World Meteorological Organization. He got an IMO prize. Also the AMS also has recognized that work, so very prestigious work. And so he's going to talk about that, the idea of predictability in the midst of chaos, and also the evolution of numerical weather prediction to numerical climate prediction. Today, he's also joined by his wife, Anastasia, and daughter Sonaya. So please help me welcome Jagadish Shukla.
Hey. Good afternoon. This is a great pleasure for me to be here at Goddard. Goddard is probably the unique center of excellence among all NASA centers, which has excellence both in the earth science and also in the space science. I think the earth science group is one of the most distinguished in the world, and of course, you also are the home of the James Webb Space Telescope. So this is really an amazing place, and I worked here many, many years ago. I worked here from 79 to 83. So I'm still happy to see a lot of faces that I had actually met when I was here. But I'm also happy to see a lot of very young faces. These are the students from Maryland and George Mason University who have come and joined in this. And of course, Charles, thank you for inviting me. This is an amazing series. You know, we as humans like to talk about ourselves. So, so it's just it gives you a blank check. You can talk about what journey you have been through. And he told me the key word was journey. So what do you do when you go on a journey? You take pictures, right? When you go on a trip, you take pictures. So my talk is really going to be mostly a slideshow through this journey, space-time of life. You know, just think of it. But I thought that would be too boring for many of you scientists, so I also added an intellectual part of the journey. And I'll really describe some of the scientific ideas that I have been involved with, and how the ideas develop, how in a scientific research, once you get an idea, what do you do next? How does it lead into a sort of a real contribution to science and advancing society? So I'll try to give a few examples of that. But in a talk like that, there is also possibility of appearing to be bragging about what you have done and so on. Please, just want to make sure that my life is mostly a random walk. Okay? There was nothing. I mean, as you mentioned about village, I'll show you some things. For my early life, it was a pure random walk. You have no idea what is going to happen next week, next year. So you just go. And during this journey, I mean, I have met so many people who have helped me. Many of you are here, by the way, in this room. And so rather than identifying everybody, I'm just going to say thanks to everybody. But I will take the time to recognize, I mean, you know, you really need the love and affection of your family to be able to do anything in your life. In your life. And you know, my wife and my two daughters, Pooja and Sonia, have been great. Pooja and her family are not here, but my wife and Sonia are here. Thank you very much. You already saw them. Thank you, MANIAC, for doing that. Thank you. What I like to do in a lectures like that is first simply walk through the outline, just orally. So in a way, I'm going to give you the oral journey before I really jump into the actual PowerPoints. And I think Charles already mentioned, I was born in a very small and primitive village in India. How primitive? Well, I'll show you some pictures, but just remember, nobody had soap. There was no soap in my village, actually. The soap will be used only like once a year on some very special occasions. Of course, no roads, no power, no drinking water, and no school. So my elementary school was under a banyan tree, and every time the monsoon rains will come, we'll run into so there was a shed for cows. So you just go there once the thing is there. And yes, the next school away was 3 miles. You walk barefoot. I didn't have a shoe till I was about 12 years old. So that's one consequence of that, and my wife reminds me all the time, every time we go to buy shoes, I need wide shoes because my feet are so flat on the okay, so how do you get from that to MIT? So you'll see these kind of several transitions in my talk. And when you have so many transitions, it's a question which stories you want to tell. So I have chosen a few. Although the college has no school and no science, I managed somehow to get into science, and I'll tell you this story. Ended up being in oil prospecting to MIT, then from MIT to Goddard. Each one, is just quite a random story, just a luck. I have to use the word luck. I have not studied meteorology, and I ended up arguing with a man whose name was Charney. And then later on I found out he's a very famous man. Well, that's how I ended up at MIT. I'll tell you about that. I came to Goddard. Of course, I was very lucky. Goddard was so nice to me. I was not a U.S. citizen, but they gave me a civil service job, thanks to Milt and David and Meredith and so on and so forth. So in addition to the professional work, then I will also give you a little bit story about the Gandhi College. That's something that my mother just shamed me into asking. You were doing all over the world, you were doing this. What have you done for the village? And I thought, that's a good question. I think that. So my wife and I are really working hard to try to help the girls in the village. I'll tell you a little bit about that. And after all that, I thought you should talk a little bit about the scientific ideas. And I chose these 3 scientific ideas just to give you a little bit of background that how you could get exposed to them, what do you do next. And then I'll mention a few words about the science and politics of global change. Because in the month of April, I had a symposium. There were 200 scientists all over the world. And we had a wonderful time talking about this symposium. In the month of September, I was labeled by Fox News and Wall Street Journal as the most dangerous man in the world. In this, one of the, out of 20. I was in the list of 20. I was number 3. Anyway, but then I would like to end by some ideas about the future, because I have been thinking about some of these ideas are old, and I'll tell you the story of my failures also. I have tried to create a word center for modeling, and I have failed. And I was so delighted to see the display into the lobby of this high-resolution model. That's something that we have been really trying to argue for a kilometer-scale global model. And then, of course, I'll give a few concluding remarks. So this is the kind of journey. I just say I will go one step at a time. I think I have already told you about village. You should. This is map of India. This is UP. Okay, that's a state where I was born. One of the most backward, one of the most poor, and most populated. If my state was a country, it will be the 5th most populous country in the world. 200 million people. And that state has 70 districts. I'm from one of those districts, and that's where. And I went recently and took a picture, and you can see that you feel like you are in some kind of a biblical village. The only thing I feel quite good about is that I left the village to come to MIT 45 years ago. And every year I have gone to my village, sometimes once, sometimes twice, because all the things, because I love my village. Turns out villagers love me, and I turned out to be a villager when I go. It has been a wonderful journey, and I'll tell you a little bit about that. As Charles said, yeah, this was my first vehicle. Well, not my vehicle, but a source of transportation, going from the village to the city, 15 miles away. But of course, nowadays, people are not using it for transportation. Now they're just using it cruelly to carry sort of food, and vegetables and stuff and so on. I think that that's an entertainment. This is interesting. So last time I went to my village with many of my friends from the universities, and my friends in the village put up an entertainment for them. What do you do for entertainment? You bring some elephants, bring some horses, and let them run around. That sort of. I myself was the beneficiary of quite significant transportation by the elephant, especially when you have some wedding like 10 or 15 miles away. And I think that it's so funny. I was a student at MIT. I went to the village, and the principal of the high school found out I'm in the village, and he said, "Please come and give a lecture. The students wants to see." But there was monsoon rains, and there was a small kind of river that 2 or 3 feet. And I said, "Look, I can't walk through that, and my bicycle will not go through that." And he said, "Don't worry, I'll send you an elephant." And so then, they have no excuse, you just go. All right, this is the, now this is not the kerosene lamp that I used, but this is the kerosene lamp. I actually sent an email to somebody in the village, send it. I said, "I'm giving this lecture." So they sent it, and Charles was absolutely right. There's so much smoke comes, but this is the only source of power. When I was in the primary school and high school, and in the elementary school, this is the notebook. I don't know how many of you are from the village. It's a wooden plate, and you write it by chalk, and you have to erase it at the end of the day and fresh start again. That's it, because there are no paper, there were no pens in the village. Okay. And you do that, of course, nowadays, they don't use it. Some of them are still using it. So the question is, so what happened? How did, from this elementary school, I ended studying science? And there, you have to recognize the great role of your parents and your family and your society that plays. My father was determined that I have to study science. So there was no science in the village. There was no science up to high school. So I studied economics, Sanskrit, Hindi, and math. And luckily, I did get good grades into Sanskrit and math. It is called a very high grade. And after high school, my father goes to a college which is 15 miles away, which has science. And he said, "You have to get my son into your science class." And the principal says, "Come on, he has no science up to 10th grade. And my father says, "Come on, you are a Brahmin, I'm a Brahmin. You got to do something." And the principal said, "Listen, we can take a test, entrance test, and if you will pass." And my father comes and he buys the science books for 6, 7, 8, 9, 10 and says, "This summer you are not grazing cows. You are reading these books, and there will be a test." And there was a test, and again, thanks God, I passed the test, and that's how actually I got into science. This is the unfortunate part of the village in India, is that things are still not changed much. This is the picture of the village I just went recently. So the banyan tree has been replaced by 2 rooms. And actually, I had another picture, which I have lost it. I went one day in the morning to take the picture, and there were 2 or 3 cows in the classroom because there's no door, and they were doing. So things are actually have not changed much. And that's the story about, you read in the newspapers, India is one of the emerging powers and one of this and that, the economic powers, but the 60, 70% of the village. And I have to say, I feel sorry. I have been trying to do something about the village primary school, but I can't, the bureaucracy, because they are run by the state government. So the only thing you can do is totally private. So that's why we worked on the college, and I'll tell you. So the story going from this elementary school to MIT, this is an MIT building, okay? I think that this is I will be very fast because I don't want to really bore you with the details, but this is what happened. My father made sure that I study into this university 100 miles away from the village, and you can take a train and go there. And I studied geophysics and oil prospecting. But the way randomness controls your life in India, but I ended up getting a job in a meteorological institute that I had never heard in Pune. Now actually it is considered one of the distinguished institutes of tropical meteorology. So I was working there in Pune learning meteorology for the first time. I took a glossary from the meteorology, and that's how I started learning meteorology. I used to learn, but I think that I like to do programming. So I learned how to run a barotropic model. And they were all punch cards. You have to learn how to punch, which I didn't know very well, but you learn to punch cards. And there was a great motivation to learn that and punch, because the only room in that institute which was air conditioned was the computer room. So you just go there and you learn how to punch. Anyway, IITM was kind of happy with what I was doing, and they nominated me to come to the United States on a fellowship, United Nations fellowship. United Nations used to give money to the people, developing countries, and they gave it. And that was, by the way, quite an experience. I skipped some classes in the primary school, so I actually did my master's when I was only less than 19. So by the time I had this job in Pune, I was actually, no, by the time I was sent to USA, I was 22. It was the most unbelievable experience. The only places I haven't before is my village, then to Pune. And those days, and it was Washington actually. I came to Washington, it was called NMC. This used to be called NMC. And you know, I couldn't find the picture, but you could just walk into White House, back lawn, and go. That's how little the security was, because there are two of us had come. Anyway, during that trip, they also sent me to Japan. So it was fellowship, 6 months, 4 months in USA, 2 months in Japan. In Japan, I met two great scientists, Gambo and Nita. Those who are in the numerical weather prediction might know. Gambo was one of the very senior Japanese scientists who was at the Institute of Advanced Studies along with Charney and von Neumann. And it was pure, that's what I say, pure luck. And he told me to do some numerical experiment. And I don't know what I'm doing. I just tell you, I just hadn't. But they had supercomputer and ran this two-layer model. And the experiment was basically try to see if there is a vertical coupling in the tropical atmosphere. And Charney has written a paper a few years ago that tropical atmosphere is not vertically coupled, it's barotropic. And this paper had got a lot of attention. Gambo told me, let's do an experiment. Let's change the vertical coupling. How do you do that? Just change the Richardson number, low to high. So we did the experiment, and the result came out, oh, there is, if the Richardson number is low, there is a vertical coupling. And luckily, next year, so this was in 67, 68, there was a symposium in Japan. And Gambo got me to come to the symposium. Well, there's a long story how in the Indian bureaucracy I got to the symposium. You don't get to a foreign travel in a very bureaucratic country. And I'm told that the only reason I did it is because the director general, who really controls everything, was trying to decide between two people who really wanted to go, because they have to one, and he didn't like any of them. And he told his assistants, I don't like any of them to go. Is there any third way? And his assistant said, there's this fellow in Pune, you know, he has a paper. Oh, great, let's send him. So I end up in Pune in an international symposium as the only person from India representing numerical weather prediction. And again, I had no idea what is going on. I go there, and then I realize that I'm going to criticize a work that was done by Charney. So I asked people, who's Charney? And they said, that guy is Charney. So they said, okay. But if you haven't studied meteorology, if you have done art prospecting, you will know what Charney is. And I said, so as soon as they showed him, I found that every time he raises his hand, the whole room becomes totally quiet. And if he gets up, 10 Japanese cameras taking his picture, boom. And I tell you, by that time, I was so scared. I says, I'm going to actually say something that is critical of this guy. But again, I don't know where from that nervous energy comes, and I always sort of give credit to my parents and to my village and my friends. I actually went back and forth with him. I was very nervous. So the chairman came and told me and said, look, you're talking too fast. Japanese people are not following it. Can you please slow down? He didn't know how nervous I am. That's why I was talking too fast. Anyway, he actually, at the end of the lecture, any questions? Nobody raised their hand. Nobody. And I said, this is over. This is great. Then Charlie raises his hand. I have 4 questions, by the way. This is all in the NWP symposium proceedings. And he said, 1, 2, 3, and his last point was, what you have done proves my paper, not that there was anything wrong with it. And anyway, that would have been the end of it, okay? So here is the thing. You have to know how events change your life. He just came to me at the end of the session. There was a coffee break, and he came to me. And he said, he started explaining me again. I did say that when Richardson number is small, this happens. And when, and I was referring to, and I told him, but look, I'm interested in the monsoon. And in the monsoon season, there's a lot of vertical coupling. The lower atmosphere and atmosphere is very coupled. Yeah. Then he says, okay, let me give you another paper. He has written another paper, a further note on vertical coupling in the atmosphere. And that scene I will never forget. From the lecture hall, I am walking behind him, and behind us, 12 people are walking. Why? Because he was the chairman of the global GARP, Global Atmospheric Research Project. And all these committee members were trying to get hold of him for a meeting, and they couldn't. And their plan was to meet him. Anyway, I went to his room, and he gave me another paper, and all these people are standing at the door. The reason I'm telling you that story is because that day, when I went back to India, I decided I want to study with this guy, if he will ever take me as a student at MIT. So I went back to India. I wrote a letter to him that I really remembered Professor Charney. We met in Tokyo, which he never replied. And now I know what happens, right? You get these letters like this. I get a lot of letters like that now. But he did give the letter to Norm Phillips, who was the chairman of the department. And anyway, to cut a long story short, I get admission and came to MIT as a graduate student. So that's sort of the long story of how I went from my village to MIT. Okay? Now look, luck. Again, what happens to the luck? These 4, now those of you who are in meteorology will recognize these names. Why I'm showing you this? They are all my thesis advisors. How lucky you have to be that when I went, Charney and Phillips became the thesis advisor. Then many of you know Phillips left MIT and went to NCEP, and then Charney and Lorange became the thesis advisor. And then Charney went on sabbatical to Israel, so they shipped me up to Princeton as a visiting student, and Manabe became my thesis advisor. So these were sort of, and this period at MIT was so wonderful. I mean, I came to know very well, the other distinguished professors like Henry Stommel, Victor Starr, Manabe at GFDL, Namayas, Eliasson, Mintz. We became actually a good friend. Pierre Sellers and I worked with him so closely on this. And so many friends, my classmates, were on the same floor. Mark Kane, Ines Fong, we were all, Antonio Moura, who is now the head of the Brazilian Weather Service, they were all classmates. It was a wonderful time. So I think that that journey and that experience was really wonderful. I don't want to really detour, but I have to tell you honest, I have to tell you that for a moment after all that, I felt meteorology is not a good field. And I was thinking that maybe I should switch and go back to India and run some elections, but I didn't do that. There was many other things happen. But from Goddard, I managed to come from MIT to Goddard. And I just say, some of you probably will recognize yourself. I can see you into this. I tell you, the Goddard thing was really so interesting. So Charney and Halem and Jestro managed to get me this joint position between MIT and NASA. And I used to commute between MIT and Goddard and GISS in New York. And then the GISS group moved to here at Goddard. So Milt Halem's group, which is called, named as Modeling and Simulation Facility. Joel, were you in New York and you came here, or you were here?
I was his first civil servant.
So yeah, right. So that's the anyway. We moved, and by the way, so Milt was my first boss. I told him, also my last boss. I didn't have a boss after that. Well, just changed the field, and which was so wonderful that all these, and it was the most wonderful time, and because you have. And those friendships are actually containing, in fact, Eugenia and me were the Milt was the branch chief, and Eugenia used to say, she and I are the twigs in his branch. Okay, so I was like taking care of the climate, she was taking care of the weather. And and then I looked at your MANIAC talks, and I said, my God, look at that. How many maniacs are my friends? On the, and Milt, Marvin was there in the other branch, and Milt always used to bring up a lot of visitors. Really, we had a lot of visitors. And we got to make some really, really long-term friends. I mean, I'll show you one guy that you recognize. See on the left side, this guy is cooking, in my kitchen. Chicken korma. He was a very good cook, okay? And then, of course, with my wife, he became a Frenchman for the other. But the reason I want to show you that is because these friendships are enduring. They are just enduring. This is a picture taken only a few weeks ago. So these are really the Goddard experience. But anyway, let me just run through this. I really wanted to thank Goddard one more time because Goddard did give me their medal, which is really one of the wonderful things to receive along with it. So that's the second part of journey I want to tell you about. I do have some time left for the science, but anyway, it's more fun, right, to talk about stories. So I think that the most interesting, and I'll give you a little bit of science, is that what I learned at Goddard, before is that, at that time people used to think that weather prediction limit is 10 days, 15 days, because the butterfly effect of Lorentz was the most dominant scientific theme. Now, as I showed you before, Lorentz was one of my advisors. He's a great genius. I somehow didn't quite feel comfortable that nature will be so cruel to us that there's nothing predictable beyond a certain number of days. So I actually started a set of numerical experiments to see, is there any predictability beyond weather? And I kept finding evidence that actually long waves are more predictable than short waves. And all this limit of 5 days is really based on short waves. And long waves are the one where a lot of energy is there. And then I kept finding that the boundary conditions have really a very important influence. Boundary conditions of sea surface temperature, soil wetness, sea ice, snow, vegetation. And we did some experiments, and we came up with this idea that if these boundary conditions can be measured and modeled, we can have more prediction. And this is something that was wonderful, because right here in NASA, because till that time everybody was saying we need all these measurements so that we can describe climate. We can describe the nature, we can describe the four-dimensional structure and variability of atmosphere, ocean, and land. And we said, you need these also for prediction, because the only source of predictability is in these boundary conditions, and that's where we grew. So that was actually the fundamental scientific outcome of this. The only downside of that is that you need a room of 10 people where you have an expert of atmosphere, ocean, land. So I just wanted to be on the record, tell you that I didn't leave Goddard because there was anything wrong with it. I loved my time. I have still my friends. We came up with the idea that we need a collection of scientists. You have such a collection in Goddard. The only problem was you had to go through 3 divisions: atmosphere division, ocean division, and land division, and about 6 branch chiefs. So that was sort of, we wrote a proposal to the university, and that's what we got, because it was that was the whole kind of the basis for creating a center of the ocean, land, atmosphere. For Jim Kinter, director of COLA and business manager, and I, our primary mission became to create the best possible research environment for cola scientists. And I tell you, that's another wonderful story because it takes actually quite a good luck, right, to be able to have people that you can work with. I mean, we have been working together, this group have been working together for more than 35 years. This group is almost 15 to 25 years. And I'll show you, we have sort of moved to George Mason. And it was the most wonderful, scientific, exciting experience because we did a whole bunch of numerical experiments from AGCM. Then we learned how to do the ocean modeling, did the process, and go from atmosphere model to the couple modeling. We worked actually very close with Goddard, just at the formation of GMAO. And it's wonderful to be able to go to work every day and be excited about going there. We never had really a bad day, I will say. We got a lot of students to do PhD. We managed to work with a lot of international programs, MONAC, TOGA, GWAX, GLASS, CLIVER, WCRP, just the whole acronyms. We got to do that. So it was really a wonderful experience. And I think that led to the creation of a whole new PhD program at George Mason University. This is, again, a wonderful, I used to say it's like a marriage made in heaven. COLA was an independent nonprofit. There's no tenure positions. George Mason was willing to give 10 faculty tenure positions. So we sort of all moved there. It is a department we have created. I had to pay the price of creating a new department. It's not easy. By the way, once you go back to the university, you can imagine a state university, as you have the usual rules and regulations. But we do have now a PhD program, and we do have a department. So I think that the whole COLA group has moved there. I showed you, and now we have a full-fledged department. These are I have to again acknowledge Goddard help. So when I was there teaching in the beginning at classes in climate, they said, we really want something more than just the atmosphere. I said, ocean, we want ocean. I said, but where do you get an oceanographer? There's none. And then I heard that Paul Schaff was retiring or taking retirement from Goddard. So he was my second faculty hire at GMU. And we have now a department. So I think that I have told you the journey by pictures. And I will take a detour to tell you a little bit about my village. But before that, I'm going to show you some pictures. I'm telling you bragging photos because they're really bragging photos, but they're also, hopefully, there is something to laugh about them behind these pictures, okay, without offending anybody. So this is the picture, of course, with, Pope St. John Paul II. And there only, so anyway, so I took to my village, and the questions I was asked is that, how come you are hanging around with people in long skirts? So you would say, this is how different cultures are on this. I think that the other bragging photo is with the Indian Prime Minister. And this one I wanted to show to my younger people. So somehow I was asked to meet him when he came to White House. And I was asked, he wants to know what's going on in India, in the Weather and Climate Department, and how to do it. I met with him in the Blair House, and I was so nervous. Should I tell him the truth, or should I just tell him what normally people tell the prime ministers? And I told him that, sir, I think it has really there are a lot of things have to be done. And I was thinking this will be my last meeting with him, and you are not going to believe what he did. As his aides come to remind him that he has another meeting with the chief of the World Bank. He was waiting in another room, and he gets up and he says, Dr. Shukla, do you have a card? I said, oh my God, I know, I don't carry cards. He says, sir, you don't need my card, just tell me. He said, no, next time you come to India, you meet with me. I met with him. Anyway, what he does, he makes me the chairman of the India's Advisory Committee for Weather and Climate. He creates a new ministry of weather and climate and all that. This is my picture with the governor of Virginia. And the reason I want to show you is because I thought this will be a great chance to make changes in the Virginia's policy about climate change. Well, guess what? No luck. Absolutely no luck. The Virginia climate, I'm a member of the climate commissions, has absolutely no recommendations, so you'll fall asleep if you read them. And I really appreciate Maryland has really a very aggressive policy. This one I like to show simply for one reason, is that when I took this picture to Judge Mason, there was a new assistant, and she says, Dr. Shukla, is this your wedding picture? I said, come on, I didn't get married. She doesn't know. She has never met my wife. She just joined it and so on. Well, I had to explain to her, no, this is the President of India. This lady is the President of India. And it is one of the things the Indians like to really do, big ceremonies. This is one of those presidential awards and honors, and they learn from the British, do it very well. But the picture I'm very proud of is my mother. So this is the picture in my village. By the way, this is what we use. This is a cot that you sit down. And I just say, when I look back, I feel that my father was very clear. I need to get good grades. And my mother was very clear. You have to do good things to other people. You have to help people who are actually doing. And she actually asked me that, what have you done for the village? And then my wife and I basically decided, okay, we are going to start a college in the village. And the biggest problem in that part of India is cheating. Nobody actually follows the rules. Teachers don't teach, students don't go to the class. At the end of the examination time, they cheat. This is a picture that was on the web. Many of you might have seen this. It's very near. These are the people who are helping the students inside by throwing chits and so on. And they have kept a person a few miles away with a squad car. And because before, the police used to fly, they used to call flying squad, not fly, but take a jeep and fast drive and catch them. Nowadays, because of cell phone, they can do that because there's one guy is watching when the police car is coming. Anyway, so we decided we're going to build a college. So this is the beginning, the same place where I used to graze cows. We really started a college, and as again, I'm happy to say that we have a college. We named it Gandhi College for the simple reason that it has to follow the Gandhian principles. We don't. And by the way, there are a lot of people, have actually helped us. And Gandhi's sort of, message is what we try to use to inspire these people. We give girls bicycles. So most of them walk, and some of them come on bicycle. And there have been a whole bunch of people. We try to build a library. And, this is such a nice thing to see these kids from the village, sort of all excited going. We have, so it has, not that their economic life has improved, but tremendous change in their self-esteem. And, so because we made this, a lot of people have come and visit. Thank you to many of you. We have a whole group called Friends of Gandhi College. A lot of people come and visit. So that's the part that I was hoping that I can do in 30 minutes, but I have taken more than the 30 minutes. Let me just tell you the 3 science stories. Now, what I'm planning to do now is that these 3 ideas, and in each case, what happens, and I think that the reanalysis is the simplest one, and I have to simply thank. You see, if you have an idea, just say it. That's the message for the young people. My office was next to Milt's office, Milt Halem's office. Eugenia's office is next door. NASA came up with this global habitability project. Come up with some idea. What do you want to do? And because I was influenced by Milt and Eugenia, I said, listen, how about reanalysis for 10 years? This was in this. And everybody was saying, oh, no, you want to go back 10 years? Who will collect the data? Who will do? Anyway, as you can see from this history, I think that reanalysis has just exploded on the field. In fact, you cannot do climate research. But the reason I want to show you that it was not easy. It was very challenging to convince people. And you have to just, if you believe in something, go and tell your boss, I think this is something that should be done. The more interesting story is, of course, of the land atmosphere. You know, the way our field has grown, National Center for Atmospheric Research, NCAR, right? Why? Because we thought atmosphere is very important. Then you have Institute for Ocean and Atmosphere, because we think ocean and atmosphere is very important. We were the first one to say land is very important. So we named it, and it happened in the most kind of unusual way. I'll just tell you the very simple story. Charney had done the albedo experiment. You guys must be aware of how the albedo affects Sahel drought. And he gave me his paper to read as a student. I was a graduate student, and the paper was written so badly, but I had no courage to tell him that. Yeah. So I went to Yale Mins. I said, Yale, this is so badly written, but how can I tell to Charney? He read it. He says, this paper is written the way he teaches in his classes. It's awful. And I said, you are absolutely right. That's the way his classes are. Anyway, we had the courage finally to tell him that the most important result in your paper, you were just not even talking. That was how the soil wetness affects rainfall, not albedo. Albedo part was sort of, anyway, to cut a long story short, and thanks to all these heroes in this, I mean, I learned land. I learned, and eventually we ended up having a model called simple biosphere models. This guy, Pierce Sellers, came up with this. It was his model, SIB model. And then we had a Japanese visitor, Sato. He just sort of will work during the night and sleep during the day. and he implemented it. So I think that just to be able to think something sort of outside the box, that, you know, maybe land can be just as important, not just for variability, but also for predictability. So Yale and I actually did this experiment, and I'm just showing you just for the historical purpose. We basically changed the whole world into a parking lot. Beta is equal to 0. Whole world is a parking lot. And then again, to change the whole world into a wet soil, in like a swamp. I just do 2 experiments. What happens? This was like, you know, absolutely the largest change you can make in land. And we were amazed that everywhere the rainfall decreased by 50%, everywhere, except a few places it increased. And that was quite puzzling to us and gave us a lot of clue about how the land and dynamics interact. But what was really amazing is that the temperature change was 30 degrees. So if you change your globe to a parking lot, according to this old NASA glass model, by the way, it was 30. So it just sent this message so loud and clear that, look, there is actually a major factor that we have to, and we were really amazed how this whole field exploded with field experiments, satellite measurements, you know, the measurements of land, measurable albedo, vegetation. I haven't got slides for this guy, Pierce Sellers, took me to fly into the airplanes, measuring land surface in Kansas. Do you remember that? It was that. It was, anyway, it was just such a wonderful experience. So I think my last scientific point, which I really need to go fast on this, is that this idea of predictability in the midst of chaos. So the dominant factor was that there's no predictability beyond. And this was the idea of Lorange. And I did talk to him and talk to Charney, and I had some ideas, and they both encouraged me to pursue these ideas. That's only the great thing about great scientists. I said, because it makes it clear that, look, we only said that it's not predictable if you're looking into instantaneous state of the weather. But if you're looking into the monthly or seasonal means, it is predictable. That was really the understanding, that we're really trying to predict this. And as I say, Lorange was great. He came to NASA. You know, we'll study under the feet of the master. And basically, this was our hypothesis, that yes, weather cannot be predicted, but maybe averages can be predicted. How do you prove it? By the way, you couldn't find a room filled with people, 20 people, who are willing to accept that things are predictable beyond 10 days, 15 days. And so we did this experiment, and we said, okay, let's take the atmosphere in completely different years and integrate them and see what happens. Because in predictability, they diverge, right? That's what you lose is the predictability. Our trick was, we said, look, the solutions converge. So what was the trick? The reason the solutions they converge is because they had the same boundary condition, not because of the initial condition. So that was the basic experiment which really proved that, and not only, look at that, this is the 100-day mean rainfall based on initial condition 88 and 82, as large as you can. This really had, so in fact, that's the title of the paper in Science, Predictability in the Midst of Chaos. Look, they're almost identical. That means solutions really converge, and not only that they converge in the, I don't, so we thought, you know what, we really have to sell this idea that, look, if you have a huge El Nino, you have a huge boundary effect, these fluctuations in the weather will not affect. That's where the predictability has to come from. And not only they are converged, but they're very close to observations. So that basically started the, I'll just, that you can get very good simulation of the boundary conditions. So these were really the three ideas that I want to tell you. And I think that the last idea about the science and politics, this is what I was telling you. In April, Pierce was there, many of you were there. You had a huge impact of science, and I was having a wonderful time. A lot of people came. And look at what happened in January. So what happened? So you express your opinion, and this is what I just wanted to leave you with a message, that so as a scientist, we really have to defend the integrity of science. There is, because it's unbelievable how, at least in this country, there's far more controversy. And there's 20 scientists, we wrote the letters to President Obama, and it's just total, just a constant harassment and intimidation of the scientists. Many of you here in the room who have, I'm sure, you have felt that. So I didn't want to dwell on it, but this is something that you can see it's a major scientific societal issue that we are facing with. But I did want to really tell you a few things about the future, because where do we go? And this is something that I believe that, so the picture in your lobby is fantastic. That is GEOS 5 picture, okay? We have been proposing for a number of years that, and this, in fact, we did it formally at the World Modeling Summit for 7 years ago, but I say we haven't succeeded, that there is still a lot of predictability that can be realized. But why we're not able, it's not the limit of predictability. It is that we do not have sufficient observations to define the initial condition of the whole climate system, ocean, land, atmosphere, cryosphere, and the chemical composition. And we do not have good models. So this is what we have been proposing, that we probably need a major international effort. How major? Just like other international efforts we have. It takes many, many countries. So, I mean, we ask ourselves, how come we don't have a CERN for climate? Or 2 or 3 CERNs, this is our proposal. And we actually made the point that, look, you can't say that, oh, I have a modeling group at Princeton, I have a modeling group at Goddard, I have a modeling group at NCAR, and modeling group in England, and therefore we don't need any more. Our argument is that, look, all these countries have huge accelerators they had. Still, none of them had enough power, 250 gigavolts, so they created a 7 teravolts machine. Why can't we do the same thing? This is an old picture. I didn't have time to really update it. Why can't we do the same thing for our field? So we actually have gone ahead, put down a proposal. We have published in the BAMS, and we are saying that, look, while all these centers at GFDL, NCAR, Goddard, England, France are flourishing, let's continue to support them because you need a lot of scientific research. But in addition, let us create a few truly international efforts which are much bigger than we can actually have. Normally, a model development group for climate model has 20 people, 30 people who are working on boundary layer, radiation, convection. We're saying that's not good enough. You need 200 people together working on developing the next generation Earth system model. And get young people and guarantee their career support for next 10 years. You can ask a postdoc to work on a model development, Earth system model, and say after 2 years, by the way, we don't have funding for you, or you are not going to get a tenure, or we're not going. So we really need a fundamental change in our sort of thinking if we want to make next generation model. And we have to. Such a huge problem society is facing, right, about the future of humankind. So this is our proposal. I just say we haven't really succeeded. So I want to tell you, that doesn't stop me from talking about it, because hopefully, my friend Tim Palmer, he even wrote a paper in the Royal Society 2 weeks ago, still asking, let's try to do that. Our suggestion is that you have to have 3 of them, okay? So it has to be a truly international sort of collaboration. Again, I just say, considering the politics in the world, by the way, can you imagine how unrealistic it is? But I feel, and that's what I tell the young people, if you have an idea, go ahead and say it, no matter how unrealistic it is, and no matter what will happen. We really think that the only way for society to answer some of the big questions that we have to ask about our future, you really need observations and very good models. That sort of, so I think that I would like to come to some concluding remarks, and I would like to make sure that we have some time to discuss and ask questions. So if you look at, I mean, this may, I don't want to be either bragging or I don't want to be a preacher, because I'm not a good preacher. But if you look at it, I felt that, okay, Charles said, what is your message to the young scientist you have to say? I said, okay, I'll tell you a message which also hopefully reflected into some of the things. So I have 2 messages. One as a scientist, and I think that this topic and the group that I showed you, and this is as a, you know, if you're working with a lot of group scientists, it's a question that you are faced with all the time. The next paper I'm going to write, is it going to go in my list of publications, in my resume, or is it really advancing the science in some way, number one? Now, please remember that I'm totally aware of the challenges in society. I have been in many selection committees and promotions of tenure and so on, and this is the way society is now. First thing, how many papers he has published, or he has published? How many of he is first author or second author? How many citation index? So we are faced with this challenge. At the same time, it seems to me that one has to be conscious that we really do. But the second question, which has been very important for me, is that what I'm doing, is it helping society in any way? My MIT PhD thesis was a theoretical study. It was instability of a flow which has horizontal shear, vertical shear, and convection. And you needed to do that for getting a PhD from MIT. And later on I find, you know, I really rather like to see if I can predict the next drought. Because after all, that's one of the biggest problems monsoon forecasting had in India. So that's my question as a scientist. As a citizen of the world, I think that I still feel very much inspired by my mother, that, okay, have anything changed because of what you have done or what you are doing? Okay, it doesn't change. Have you left the place better when you came, whether it is a meeting or whether it is a village or whether it is a city or whether it is a world, or whatever it is? So I think that my last comment is to the young people. Let me just say, because it is quite possible that you find that our field has controversy, there are not enough jobs, and so on. But let me just assure you that you are basically seeing the dawn of the golden age of our system science. It is developing. I mean, look at coupled ocean atmosphere model. It was not there. I just saw it for the first time when I was a student at GFDL. There is so much unrealized predictability in the system that you can explore and harvest for the benefit of society. I think that society is counting on you to give science-based advice about how to manage the planet. I mean, look what happened in Paris. 200 countries got together. Why? Because the scientists have said that global warming is real. Can you imagine 200 governments taking the conclusions of a scientific community? That is how important our field is. I think you have chosen a great field, and I think there is a great future ahead of you. Go and change the world. Thank you very much. Yes?
What's the science problem you're working on now?
I'm working on both the predictability of, I didn't tell you another story, is that while monsoon is the interest where I started with, one of the worst simulations on all the models now is a monsoon, the Asian monsoon. And if I showed you the CMAP3 and CMAP5 simulations, you can figure the difference between the errors. That's how it is. Of course, the other thing we are working on that how do you improve model fidelity? Because predictability completely depends upon the fidelity. But of course, I'm also interested in the academic part. There's a more, we have a climate dynamics program, of the PhD program, and beginning to get interested in how poverty and climate are related. Because here's the thing, look at that. Who will be affected the worst by climate change? The poorest people. Where is poorest nation? So my interest has also moved from climate to climate and poverty. And then ultimately to really inequality in general, because so climate change becomes really an exasperating factor into this.
Thank you for the great talk. I think you mentioned about the incorrect knowledge of the physics is the main obstacle for the unexplored predictability. Do you happen to have some prioritized list of inaccurate physics you think we have to understand better to improve the predictability?
Yes. I think that, as I told you, one of the major barriers of predictability now, in my opinion, is the fidelity of the models. And why the fidelity of the models is not good? Because we are not able to treat the small convection, okay, the small scales, and how do they affect the large scale. We're able to do very well with the large scales. By the way, the entire progress in numerical weather prediction in the last 25, 30 years is because we are able to handle the potential velocity dynamics much better. But that we can do it to the large scale. That's why our prediction of cyclones moving from here to there much better. Our prediction of 5 days weather, the long waves, their propagation and their amplification is very good. But we are not able to handle the deep convection. We are not able to handle interaction between the deep convection radiation and the precipitation processes and its interaction with the boundary layer. So unless we make some fundamental advances in also understanding the basic physics of the smaller scale, we are not able to improve the fidelity of the models. And if we cannot improve the fidelity of the models, we cannot make the prediction. Predictability is not the property of the atmosphere. Predictability is the property of a model. You just use the model to estimate its predictability. However, if your model is not good, you may estimate it, but it may not be relevant to the actual nature. That's why our constant endeavor has to be to produce a hypothetical perfect model, which we'll never do, but that has to strive towards that. What is a hypothetical perfect model? A model which can capture all the means, variances, and covariances that we have observed in nature. You don't have to really predict actually what happened after 10 days, but you must be able to capture the statistics of fluctuations. How many hurricanes were formed? How many El Niños? What is their PDF? We are nowhere there yet. So in my opinion, that's why my proposal was to improve the fidelity of the models. And if we do that, we would need then improve our parameterizations of the unresolved scales. And we then have to go and estimate the predictability. Does that answer your question?
Yeah. Sounds more like modeling than my question is that do we have enough knowledge to model the convex small scale convection, or do we really have to go out and measure more?
Oh, I think I was just trying to tell you that there are some processes for we have enough knowledge and we're doing it well, but the processes of convection, process of deep convection, interactions between the convection, we have to do a lot more research to be able to bring their parameterizations up to that. In other words, I'm saying that you're starting out with a goal of building a model. That's why I'm asking, okay? Understanding of physical processes that go into the model is very fundamental, and we don't of these processes, which we need to do research on. And by the way, then we can say what is the limit of predictability. Now, it is quite possible that we never be able to. There will be a fundamental limit, okay, which we can't. All I'm telling you is that we haven't reached that limit yet. Right now, we are basically insufficient knowledge of these very small scales and their signs, and our inability to parameterize them to put into the large-scale models is the big barrier.